Number 64. Calculate the value of hydroxide concentration from the given hydronium ion concentration and label the solution as acidic or basic. So in problem 60, if you go back to problem 60, we saw that the hydroxide and proton concentrations are tied together. And suppose the proton concentration is 10 to the minus 4, the hydroxide concentration would be 10 to the minus 10. And if the proton concentration is 10 to the minus 5, the hydroxide concentration would be 10 to the minus 9. The equation that relates the two concentrations is given here in problem 64. It says that if you multiply the two concentrations, you get 10 to the minus 14, or 1 times 10 to the minus 14. And you can see that. If you multiply this times that, you get 10 to the minus 14. If you multiply this times that, you get 10 to the minus 14 again. So it works for any pH or any other situation. The two concentrations multiply together to give you 10 to the minus 14. So in problem 64, we're interested in the hydroxide concentration if we're given the proton concentration. So let's solve this equation for the hydroxide concentration. Let me blow this up a little bit. Solving for hydroxide concentration, there it is. And we can simply plug in the proton concentration that we're given. Okay, so we'll do this 4 times. So here are the proton concentrations. We plug those all in. And simple calculations to solve here. You can just look at the powers of 10 to the minus 14 over 10 to the minus 1. So it's going to be negative 14 minus negative 1, which leaves you negative 13. So you're left with hydroxide concentration as 1 times 10 to the minus 13. Now, this is much smaller than the proton concentration. So this solution would be basic. Let me write basic. The next one, for part B, the proton concentration is 10 to the minus 13. And when you solve with the hydroxide concentration, that's going to be 10 to the minus 1. That's much larger than the proton concentration. So this one would definitely be acidic. In part C, proton concentration is 2.6 times 10 to the minus 7. So plugging that in and solving for the hydroxide concentration, it rounds to 3.8 times 10 to the minus 8. And that's slightly smaller than the proton concentration. Proton concentration is a little bit bigger than the hydroxide, so this one is a little bit acidic. We'll still call it acidic, even if it's less acidic than the one in part B. And finally, part D, the proton concentration is 10 to the minus 12. And solving for the hydroxide concentration, we get 8.3 times 10 to the minus 3. And that's going to be much bigger than the proton concentration, so you got more hydroxides. This one is going to be basic.